All right, this is kind of in the middle of a Calculus 2 problem. We are given this guy as an integrand to integrate, and it's too difficult to integrate as is, so we use something called partial fraction decomposition and split it up into these two terms. And then we find A, B, and C values, and then try to integrate what's left. This should be much easier to integrate in this form than in this form. So in order to find A, B, and C, the first thing we want to do is multiply both sides by the least common denominator. And the least common denominator is always the one that's over there. Okay, so if I do that, on this side, if I multiply by y minus 1, y squared plus 1, everything cancels and I'm just left with 2y. On this side, if I multiply this term by y minus 1 times y squared plus 1, the y minus 1s will cancel, and I'm left with a times y squared plus 1. In this term, if I multiply this whole guy, by plus c, times y minus 1, y squared plus 1, the y squared plus 1s will cancel, and I'll be left with y minus 1. The whole point of doing the first step is to get rid of the denominator. So all we have is a nice long line of numbers instead of a nice fraction of numbers. Okay, now the second thing we're going to do is multiply everything out. Multiply everything out. So since this is already multiplied out, I have 2y. I'm going to distribute the a, so that's ay squared plus a. And I'm going to FOIL this, or distribute that as well. So by times y, by squared, by times minus 1, minus by, c times y, and then c times minus 1. The third thing we're going to do is collect like terms. That means we're going to collect all the terms that are constant. In other words, there's no variable, or that has a y squared, etc. So when I look at this, I can see that ay squared, those are like terms. By the way, the left-hand side stays the same. So I collect all the y squared terms, and I have an a plus b inside. Factor out the y squared. I see I have two y terms here, so that's going to be minus b plus c with the y terms. And then I have constant terms, a and minus c. So that's going to be a and minus c. Sorry about that. The fourth things we're going to do is compare like term coefficients across the equal sign. So in other words, when I look over on this side, I see a 2y term. So that is a coefficient of y here. So I'm going to compare it with the coefficient of y here. So this forces minus b plus c to equal 2. So let me write that down. Minus b plus c has to equal 2. Because if these two statements are equal, the coefficients of every term need to be the same. So now you're saying, well, we don't have a y squared or a constant term over here. But we can just say 0y squared plus 0. And then we have the coefficients that we want. Seems a little tricky, but it works. That means that a plus b, comparing coefficient over here, is 0. And then I have a minus c, comparing coefficients, is also 0. And then this is the system that we have to solve. Whoops, sorry about that. This is the system that we have to solve here in order to find A, B, and C. So, I mean, there's a variety of ways of doing it. In class, we did it with a matrix, but I'll do it by hand here just to be different. So I'm going to take this term here, and I'm going to say that I know that A equals C. Then I'm going to look at these two guys here, and I know that if I plug in an A value for this C, then both of these just have A's and B's in it. So that's what I'm going to do. So A equals C, that means minus B plus A equals 2, and b plus a equals 0. Now you're saying, why did you write that the other way? And don't get all panicky. I wrote it the other way so that I can compare these, and now if I add up these two lines using the method of elimination in systems, I see that the b's will cancel, and I'm left with 2a equals 2. So that means a equals 1. If a equals 1, then c equals 1. And then let's figure out what b is. If a is 1 and b plus a equals 0, so that means b plus 1 equals 0, which means that b equals minus 1. So then our final formula in the end turns out to be 2y divided by y minus 1, y squared plus 1 is equal to a is 1. So 1 over y minus 1 plus negative y plus 1 over y squared plus 1. And then from there, normally this is the original thing that you were integrating with respect to y. Then now instead of integrating that term, you integrate the sum of these two terms, and it shouldn't be too bad. If you're going to continue integrating, I'll tell you, integrating this guy as is probably won't work very easily. So let's just rewrite this as minus y over y squared plus 1 over y squared plus 1. And then it should work.